I noticed that there are still some people outside in the coffee break. But I think we should try to start the seminar on time. We got, according to my watch, now it's already the time to start. Okay. Okay. First of all, I would like to thank all the presenters. They spend their time and effort to prepare the presentation for today's seminar. And some of them also travel a long way here. I also want to thank all the participants online and also in person, especially those right now in the room. My name is Shang-Hsien from National Taiwan University. I'm the TC-34 chair. The TC-34 is the digital transformation for sustainability or sustainable development. And then TC-30 is digital technology for smart construction. So this time we got the opportunity to have kind of joint seminar. This is not the first seminar for TC-30 because they established much earlier than TC-34. TC-34 was approved in last ECM, that was about 6 months ago. And then we started to recruit the committee members. And then this is kind of our first seminar. So at the very beginning, I want to encourage all of you online and in person, try to recommend your friends or yourself to join TC-30 and TC-34. We are still developing our agenda, although in our proposal, we have already set up the website. But I think it will take some time for ASECC to put our website online. But once it's online, you can take a look at that. We lay out quite several general directions to provide the room for people to develop a more specific agenda or issue or challenges. And then we do invite people even to form a team to use the platform of the TC to address the interdisciplinary issues and also among the Asian countries. Yeah. So, okay, without further ado, I don't want to delay the presentation. So on the screen, you can see this is the sequence of today's presentation. No, this is not, okay. Anyway, I don't think this is the most current version, but I think people don't mind, right? But anyway, so let's just follow by this published one. Okay. So the first the first three are from TC-30, and then the last four are from TC-34. Okay. Originally, I mean, last week we were trying to reschedule it a little bit because some of the person cannot come here in person, and then they have to switch to the online. So we are trying to see how we can make the online and the in-person arrangement better. But anyway, let's just run it through this way. So Professor Chun from Japan, he will present online, okay? And then Dr. Ta from Vietnam, he's here, right? Okay. Do we have the slide or no? Okay. So, okay. Now I remember. There are a lot of correspondences. So, and then he couldn't make it. Okay. So we are not going to have that presentation, if I remember correctly. And then Professor Quan from Vietnam, he just left. because it's difficult for him to find the flight to go home, and so it's difficult for him to reschedule it. And it so happens that when I believe probably when TC-30 chair tried to communicate with him, he only knows that it's in the afternoon. But later on, because of this kind of joint seminar, so our schedule kind of shift to 4 to 6. And that's the time that I think his flight is like 3:30 or no, 4:30 or something. So a couple hours ago, I think he's already he was on his way to the airport. But he has already recorded his talk. So we are going to play the recorded one. And then Dr. Mony is here from Cambodia. And then Dr. Amarnath from India, he will present it online. And then Dr. Kanangkaew, is that? Yeah, Somjintana. So you use the first name? Oh, okay, yeah. From Thailand, she will present in person. And then Dr. Adrianto also will present the talk in person. He's from Indonesia. Okay, so you can see from different countries, then we are going to have very rich presentation. So in my original proposal is that after 3 talks, and then we probably can have a small break. Okay, and then we probably take a break for 10 minutes for kind of social networking, and then we continue with another 3. And then we can have kind of at the end, and then we have the Q&A all together. Okay, is that okay? Okay, now I would like to invite our first speaker, Professor Chun.
Yes.
Yeah.
Thank you very much for advertising TC-30 anyway. Okay, then let's make the presentation. Let me share the screen. And can you see the slides? Maybe yes.
Yes.
Okay, thank you very much. My name is Chun from the University of Tokyo. And the topic is experiences of advanced infrastructure maintenance technology using AI, UAV, and advancing 3D data measurement. Okay, in Japan, because I'm from Japan, and Japan has more than 700,000 bridges, and currently over 40% of them are aging. And in 10 years, this will exceed 2/3 of all bridges. At the same time, the population in Japan is decreasing, and the budget are being reduced because these days Japan is kind of become poor. So because of this situation, bridge inspections using ICT are becoming very essential. So my research group is kind of developing the method to make the inspection by using UAV and so on. Oops. Okay, I'm preparing the movie. And this blue one is a UAV. It is a very small one coming from US. And I don't know whether, I'm not sure if it looks smooth in Myanmar, but because it is kind of over zoom, but it actually moves smoothly. So please kind of modify in your brain. But anyway, this UAV can even enter such a narrow space and take photos of lots of places so that we can kind of inspect lots of bridges efficiently and safely and at low cost. This is what we are doing now. And after taking the images, we have also built a system that creates 3D models from photos, so-called structure from motion. And there's other methods include inside here. And then use AI to detect damage in these models. This not only makes it easier to understand where damage is located, but also helps us predict how quickly the damage will worsen in the future and analyze how much weight the bridge can currently support. This is what we are doing now. This is where AI comes in. By comprehensively examining data obtained through AI and automatically detecting damage, we don't need manual inspection. And damage can be automatically identified from the vast amount of data accumulated and trained. For example, sorry, laser pointer is here. This is the original damages. And from this damage, our AI can say, this is the cracks, like this. Or this is the original photo, and our AI can say, these places, there are corrosions. Then we can make, from these damage, we can make finite element model or other models to predict the residual performance, load bearing capacity, and so on. And for example, as for the crack detection, we are also developing the state-of-the-art method. We have published lots of papers in the top-level journal. This is multi-scale crack detection method published recently. We achieved extremely high accuracy in crack detection by using our original deep learning model that detects cracks at various scales and then integrates these results. The method is kind of thanks to considering multi-scale to utilize the fractal nature of concrete. Again, the accuracy is very high. And at the same time, we need to think about the environmental conditions or surface colors of the bridge or concrete and the lightning conditions. They kind of vary dramatically from bridge to bridge. So in that case, it happens that, as you may know, AI, the training images, training dataset is very important. But if the real situation is different from the training situation, the performance AI is not good. So this is a very big problem in the crack detection model of the bridges. To solve this problem, we normalize these environmental factors first, essentially making all images appear under similar conditions. Typically, AI accuracy drops significantly again when bridge condition is different, but our specially developed AI maintains high accuracy by standardizing the environmental condition before analysis. And this one is also published in the top-level journal. And let me show one application of the usage of our model, 3D AI model. This is the Oshima Bridge, one of the longest bridges in Japan. We are also developing a system for inspecting this bridge. The bridge is locating around here to connect this island and the main island. And this is the inspection vehicle under the bridge, and we put cameras on it. And this is a movie. Oops, I don't want to make the, okay. For example, because thanks to the 3D model, we can kind of locate damages or members in tablets. And I can say kind of AR, augmented reality model we can do. And by using this tablet, we can understand where the main tower is. And by taking it inside the bridges, we can get the location by SLAM. And we can understand where the damages were and what is the member likes and yes, and so on. We can get lots of information from this. And at the same time, we develop the model or software so-called InfraWalk. And let me show one example. This is the software which I'm making. Which I'm making or selling in Japan. And this is like a oops. I think I need to share. Oops. Okay. And this is a software which I'm selling in Japan. It's like a Google Street View of the bridges. By putting these location, we can see lots of things under the bridges or on the bridge. And as you may see, we can, get the information of the damages of bridges automatically indicating. And by clicking here, we can get the information of the bridges or damages. And this software is very useful for managing the bridges. And this one is also coming from our 3D AI system. And again, I'm going back to the PowerPoint slides. This one. And at the same time, we make the AI to write the sentences or captions or explanatory text from the images. Now, these days, we can do it with ChatGPT, but I developed this AI 4 years ago and published here, and which is awarded from Wiley that top cited articles. For example, if we give this image, my AI developed these sentences: exposed river detected on the main girder and spalling concrete detected on the main girder. This kind of specialized AI can make easily to develop the inspection report and so on. And this is our system, for example. Oops. For example, if we input the image and upload it, and there are candidates of the explanatory text, like a defect detected on the main girder or corrosion detected on the bearing. And by selecting it, we can make the inspection report easily. Anyway, we developed this kind of system. And here we come to the conclusion. Now, development of 3D model with automatically detected damage are shown in this research. And the system utilizing the 3D models are shown and are going to be used practically in Japan. And system to generate the explanatory texts are developed to reduce the inspection report making labor and for further high-spec decision. Anyways, this is my slides. Thank you very much for your kind attention. And if you have any questions, please let me know. Thank you very much, Chairman. Mr. Patrick.
Thank you. Thank you. Okay. Do we have any quick questions? If not, then we just leave off the question to the end.
Okay. Thank you very much.
Yeah, thank you.
Thank you.
Would be the recorded one, right? Am I right? Yeah, Professor Quan. Yeah. No voice?
This is the content of my talks. We start with the introduction and then a brief literature review, and then we present the implementation framework, the pilot VR training in Vietnam, the key findings and benefits, and the conclusion and future directions. Let's begin with some facts and figures. In 2024, the Chun in Vietnam accounted for over. Good afternoon, everyone. It's a pleasure to have a chance to do a talk at our event on behalf of my team. My name is Nguyen from Hanoi University of Civil Engineering, Vietnam, and I'm honored to present our research on revolutionizing safety training in Vietnam through the integration of building information modeling and immersive technologies. This is content of my talks. We start with the introduction and then a brief literature review, and then we present the implementation framework, the pilot VR training in Vietnam, the key findings and benefits, and the conclusion and future directions. Let me begin with some facts and figures. In 2024, the construction industry in Vietnam accounted for over 13% of all workplace accidents and more than 11% of total fatalities. The most frequent cause, fall from height, making up over 10% of fatal incidents. These numbers highlight a critical issue. Safety on construction sites, particularly when working at heights, is still a major challenge in Vietnam. Fall from scaffoldings, rooftops, or open edges are all too common. That's why Vietnamese labor law, like Circular Number 4 2017 of the Ministry of Construction, mandates safety training. However, enforcing this regulation and ensuring workers are effectively trained remains difficult in practice. Despite legal safety requirements, many workers remain unaware of the risks associated with construction activities, particularly in rural areas where a significant portion of the labor force is concentrated, but the access to safety education remain limited. Safety culture in Vietnam is still evolving, and many workers perceive safety protocols as optional or secondary to the task at hand. There's a common belief that accidents happen to others, not themselves, which can foster a sense of complacency and lead to negligence. Construction sites can be hazardous, and there are safety and liability risks involved in allowing learners to participate. Some projects may be hesitant to expose students to these risks without proper supervision and training. Some educational programs may not have financial support to collaborate with industry professionals or invest in providing access to actual construction projects. Traditional safety training in Vietnam still relies heavily on classroom lectures, videos, and slides. There's a lack of realism, limited engagement, and no real construction environment for practice. As a result, workers often lack the awareness and reflexes needed to handle real risks. Traditional education and training methods often lack the immersive and interactive elements needed to effectively engage learners in complex real-world scenarios. Traditional training lectures base limited hands-on experiences. This is where BIM and immersive technologies like virtual reality come in. We now have the tools to transform safety training into engaging, interactive, and scenario-based learning experiences. Imagine practicing emergency responses or hazard identification without facing real danger. It's great. Research shows that immersive trainings lead to better engagement, improved knowledge retention, and increased hazard awareness. However, challenges like technical limitations and customizing content for local conditions still need to be addressed. Our implementation framework, our team has developed a BIM-based VR training model specifically for working at heights in Vietnam. Here's how we did it. We collected real-world construction data and created detailed BIM models. These models were exported into Unity, the game engine, to create an interactive VR environment. We designed training modules focuses on common hazards like scaffolding or roof edge safety. The interface supports Vietnamese and English, and we tested it with both students and professionals. We also conducted surveys and interviewed with 10 industry experts to identify real-world risks and gaps in current training. Their input helped us customize the content for realistic learning. According to an interview survey conducted by the research team, 10 interviewees were industry experts with hands-on experience in the education field, actively involved in the education projects at various job sites. This is the question we ask the experts. And this is the model we developed for the framework. And these steps for us to develop the BIM-based VR training model for working at heights. And this is a video showing the results from our research. This is the result. They expressed strong interest in using VR for other learning topics as well. This is the result. We got a lot of positive feedbacks and some suggestions for potential use for industry-wide adoption. In conclusion, BIM and immersive technologies offer breakthrough intelligence safety training. They help bridge the gap between theory and practice, delivering hands-on, risk-free experiences. Going forward, we aim to integrate AI-driven customization, haptic feedback, and cloud platform to further enhance the learning process. Thank you for your attention. Since I had no chance to do it direct presentation today, I'm happy to answer any question or discuss collaboration opportunities. Feel free to contact us at the email address provided in the first slide. Thank you very much.
Okay. Now let me invite our next speaker. I forget the sequence. So will be the next and Dr. Somjintana? No? Or Amarnath? Can you go back to that schedule? Oh, okay. So Dr. Mony, yeah. So okay.
Yeah. Thank you, Professor Hsieh. Thank you, audience. Me present today more in policy level. Where, okay, thank you. Last year in November 2024, I have done. I did a perception survey, very rough survey, to see how the situation in Cambodian people practice in BIM. Before we have some idea how we Cambodian government move with the BIM implementation. Yes, so we come up with concept note that to propose the idea to decision maker politician to consider to set up the framework. So actually I have tried in the year 2018 with Professor Hsieh to set up the research center for BIM in Cambodian at one university in Cambodia, but we could not reach all the potential cooperation among the Cambodian civil engineer or practitioner, because look like at that time they just hear what BIM, but maybe no demand from outside. So they just wait, but the last few years, I think after COVID, so the demand on BIM very high. So then they start to rush to try to understand what is BIM and how to apply BIM. And one mega project airport built by Chinese contractor and designer, then they apply fully BIM. So from this stage, the people start to think how Cambodian we are moving with BIM. So the So this my place at the moment. I'm in charge of National Council for Building Technical Regulation. So we come up with the survey. So we try to understand what position in the company, organization, people use the BIM. So we have seen architect or engineer that dominant. So the level of knowledge that bachelor degree. So we see in BIM application most with engineer the complication. So they pick up the high from engineering application, and how difficulty when people moving from CAD technology to BIM technology. So they look like a 50-50, not so much difficult. So this when we compare the benefit between CAD and BIM technology, then they put BIM a very high benefit. So when we look to the life cycle of the project, so where the BIM apply, so most of them they apply in the documentation, and then come to schematic. Come to documentation, construction area. I mean during the construction, So this Cambodian situation last few months we did the survey. So during the stage they apply more in design stage, yes, and construction stage, of the project. So how they use BIM? They use in coordination the best they apply. So when we request them, the idea how the top-down approach or bottom-up approach to push or to adopt the BIM. So they look like top-down approach more better than bottom-up approach. And if we can combine this approach, the BIM application may be efficient and effective. So these are common from the survey. So they are rely BIM, and they use the. They said that BIM like they want to have the standard, the BIM standard, because when they have standard, they easy to have fair competition in the market. So something like that, and they they said they need learn BIM from the school. Much better learn BIM during the work. And they hope that in the next 5 years, Cambodian merger in BIM. So they asked our ministry, that Ministry of Land Management, Urban Planning and Construction, to have some kind of law to push especially for tall building, apply BIM. And then the BIM adopt BIM the best they adopt in detail stage, because when they modify area, it more control, and then they less the work during the correct area, And the other they need to regulate BIM. So they asked the ministry to regulate BIM. So maybe mega project like public project, real estate, foreign fund need to use BIM as leverage of the BIM. And Yeah, and our place that Council Technical Regulation, then they are support the idea that we survey the idea. So this we come up with how my place need to establish the task force for the nation. So we have to combine all the sector in Cambodian. So we have from the ministry, from our council, board of engineer, board architect, practitioner, and industry like academic and so on. So so we think how we regulate BIM, how we have the BIM standard for Cambodia. Then we look to the ISO, what ISO mentioned about this. So we come up with some code of the ISO standard. But because our people recommend for certificate to certify BIM or something. So we think all about this, so we put this into the concept note for the politician to decide. So currently this year our ministry draft three policy, main three policy, that one for construction industry development, and one for sustainable construction, and the other for digital construction. So our BIM support the digital construction policy. And our place, we do all this kind of thing, building, we call building safety category. So now at currently we are drafting technical regulation for structural safety, for fire safety, architectural design, and some structural code that we adopt the Euro code as a model code for Cambodia. And MEP, it somehow it mix, yeah. And the other, we have to develop the sustainable building. So information modeling BIM look like they support the data, sustainable of data. So this the scope that the Cambodian doing and going to do. So now the concept note. Now we are looking to the ISO 12911 for the framework. We are looking that, and we are still not start to drafting now, because we are collect the member, the task force. After we approve the task force, we move with the BIM framework for Cambodian first. And then we go down to the standard because can help to integrate the information because the ministry want to, now they are successfully to test the e-service for the public service. They can apply license, construction license online. They are tested successfully, and then they are still pending for the drawing. So drawing need some BIM or data to help. But I think it's still a long way to go for Cambodian, but just a starting. And this some kind of for proposal. So we do a concept note, we proposal for fund and for support technical assistance. So we propose the standard. So, but we still not register as a Cambodian standard, that CS, after we have approval from ISO, and then we will register as a Cambodian standard. but we need to translate to right here. So these four standards that Cambodian going to do, and we put for proposal, and we hope that in the near future we have to put this as a zero version for implement and after we write some guideline for BIM implementation guideline. Yeah. So I think maybe these are all for my presentation. I think I cannot. Okay. This I just show a little bit that our minister, that deputy prime minister, that in charge the Ministry of Land Management, and he also chair of our National Council for Technical Regulation. So yeah, so I think we will apply the top-down approach for BIM implementation in Cambodia in the near future. Yeah. Thank you so much for your attention. Yeah.
Thank you. Any quick questions? Okay, if not, then let's take a 10 minutes break. Please return at 5, okay? Yeah, so for the people online, yeah, we will take a 10 minutes break. We will start to have another 3 presentation starting from 5, okay, yeah. Okay, let's start our second part of the session. Yeah. Our next speaker is Dr. Amarnath. He's going to present the talk online. Amarnath, are you there?
Yeah, Professor. Hi, I'm here.
Okay, yeah. Please share your screen and then you can start your talk.
Okay. Professor, is my screen visible?
Yeah, please.
Okay. So, well, good afternoon to everyone. My name is Amarnath. Greetings from India. So I'm currently based out of Mumbai in India. I will be discussing today with you on how do we set up a BIM or digital department for multiple companies. So it's about strategizing BIM and digital adoptions in buildings and infrastructure projects. So I'm representing a company called BIMCrew currently. And also I represent an NGO called India BIM Association. Along with that, we are developing the standards in our country at Bureau of Indian Standards. I also represent that. So looking into country like India, there is a vision for 2025 by our government. Construction industry will be around $1.4 trillion. And the budget is getting split among the key areas like roads and highways, railways, and real estate. As you can see, roads and highways taking the 22%, wherein the railways and real estate is very closer to it. So by 2040, it's going to be 526 billion investment needed for the infrastructure within India. And this is a statistics from Ministry of Statistics and Program Implementation in India. So taken a sample of 1,418 projects, which are 150 crores and above, that's Indian currency. It has been seen that more than 346 projects are with cost overruns and 823 projects with an average of time delay 39 months in delivery. It's more than 3 years of delay. And overall, when you look in, the projects are coming up with cost or the time overruns and with 60% of the project. With this being the situation, in 2025, this is a Niti Aayog, which is under the PMO, which is Prime Minister Office for the mandates, policies, and guidelines. In 2025, Niti Aayog has taken up an initiative to bring in the mandatory requirements for BIM at different capex values. Like if you can see here, for transportation, any projects about 200 crores, railway projects or airports for 150 crores and above. Like that, they have bringing in the mandatory requirement for BIM in the projects, for projects above some pricing. When you look into the built environment within India, we have different ministries supporting the development of this built environment. It is like Ministry of Housing and Urban Affairs, Ministry of Defense, border road organizations, Ministry of Road Transport, Health and Family Welfare, Tourism, Airport Authority, Central Public Works. These are all some of the ministries which are building the nation, and they are all looking in BIM and digitalization as a priority these days. And they're putting in BIM as a requirement in the contractual contents for projects above some amount. So it has become a requirement for contractors who are class 1 or so to adopt BIM in their projects. This is one of the example, Central Public Works Department under the Ministry of Housing and Urban Affairs. They are set up the strategy for BIM. The similar way, each of these ministries are having some change management workshops, awareness sessions, and setting up a roadmap for their public client to drive the BIM in the country. And this is one of the team structure for the public clients to think about at the coordinator level, manager, and leadership. So obviously, each of these clients, when they're asking for BIM, they need some internal teams who can audit the quality of the models and deliverables. So this is a kind of team structure which we have proposed to most of the client organizations, public and private clients, to have the coordinators and the managers to quality control and coordinate the project deliverables during design, construction, and asset management. And we all know the BIM professionals are not coming with huge experience. They may be starting with 3 to 5 years and 10 years and 15, something in this range. And the next thing is at the policy level, we did not have any BIM or digital guidelines in the country till now. And I have taken up some initiative along with few experts in the country. I chair these initiatives at the Bureau of Indian Standards. We are developing different guidelines for helping the clients, contractors, and subcontractors. And also we have a national building code in our country. So we are also developing BIM contents into these codes so that it becomes a prerequisite for any of these parties to go with. One side, when the client is mandating, another side, they also need a guideline how to adopt. So we are developing those guidelines. Before 2025 end, we will have these guidelines circulated in the market for the benefits of clients, contractors, and subcontractors. And for us, BIM is two parts. One is generating the model, and another side, keeping it updated during design, construction, asset management. So that's where you have these LODs from 100 to 500 and 500 plus. And then another side, how do you use these models? When we say using the models, obviously used by every stakeholder or any stakeholder organization, starting from design and engineering teams, project controls, safety, procurement, logistics, construction management, government authorities, approving bodies, and green building consultants, asset management organizations, project management consulting firms. Everyone has to use the BIM. And this is where you get the ROI, return on investment in CapEx and OpEx. So this has been taken seriously in the guidelines and the approach with the clients today to focus more on how to use BIM rather than just developing the models. And the most important thing today in the developing countries like India is each of the companies, no matter it is a client organization or a contractor or a subcontractor, each of them need a BIM department, which is actually missing in the companies because initially most of the companies were thinking, let me outsource the work. let me get the work done from other companies. And from past 5 to 6 years in India, many companies have realized that it is not something which has to be done outside the company. It is something we have to build the capacity within the company. So now most of the mid and large size contractors and the client organizations, no matter it's a public or private clients, they're all focusing on building up their departments, setting up their strategies, allocating the budgets, and selecting the softwares, hardwares, and partnering with the companies in the market and training their internal teams. So our focus is today, this is a country where you need each of the companies having their own departments to drive the BIM initiatives in their regions. So the first and foremost is business strategy. Then comes a team building strategy, how they build their own team for BIM, either to internal training or through the recruitment. Software strategy, because in India today we have some 25 to 30 tech vendors. Which software should I choose out of this? Understanding that. Hardware strategy. Today, when you say BIM implementation, it needs multiple equipments and hardwares. So how to make a decisions on this? And next, the partnerships. Today, when you go to market, there are multiple service providers. How do I understand which is the right service provider? How the little bit detailed on each of these topics so that we focus on these things to set up a department for companies. So one is business strategy. Obviously, when you go to the company, they may be new to the BIM, or there may be already BIM in the workflow, but not fully matured. So it's about setting up their organization's BIM strategies, setting up their change management workshops, defining the project workflows, assessing their current capabilities, auditing their partners, and assessing the maturity and skills and competencies of individuals in the company, and activating the BIM implementation plan for the organization, and getting them for local guideline certification or ISO, whichever standardization requirement. So I was an employee in some companies like contractor and client in the past. So we have done a detailed setup of strategy for those companies. It's not one department, two department. It was like 90 department, 100 departments in these companies. Obviously, change management takes a lot of efforts, because someone working on without BIM in the organization and asking them to move for the new developments and asking them to learn something new is a little challenging until they feel it's going to add value for them. So we have a series of workshops to decide the vision, mission, goals, and success factors and metrics for the project, for the organization, for the transformation. So we have done a series of workshops in phase-wise, like to decide the vision and mission, goals, and the success factors and the metrics like KPIs, and develop the dashboards for monitoring, and then handle the internal team through the trainings and through the implementation on the projects. It's a phase-wise workshops, and then we develop the roadmaps and handle them. So, for example, this is one of the company which I served, is one of the top 10 contractor in the global sector called Lazan Togro. So where we had a series of workshops with departments like design, execution, planning, quality, safety, procurement, tendering, form work. So it was a 3-year plan that they have to transform in the next 3 to 4 years. And these are independent companies within the company, like what you see on the image on the right-hand side. So each of these companies had 8 to 10 departments, and we have to have the change management workshop, develop the strategic roadmap, handle them, do the POC on each category of projects. So it was a good transformation. The change management success was around 80%. When we started, only 20 to 30% people were accepting the BIM approach. And then by the end of 2 to 3 years, 80% plus were aligned with the BIM approach. And as a contractor, we were able to see minimum 3 to 4% return on investment in the CapEx phase. We were not in the OpEx, so it was only the CapEx returns we could realize. And the next thing is coming into the team building strategy. So when you look into the BIM professionals, either you can build this capacity within the internal organization, existing team who are not new to BIM, or you hire the professionals with BIM skills already in, and they may fall under these 3 categories. One is the production roles, second is the coordinator and management roles, third is advisory and leadership roles. So for example, currently I'm doing more of an advisory role to most of the companies to set up their departments. And I was in a leadership role when I was setting up the strategies for companies like this in the past. And coordinators and managers and production is like who can do the production of model, or it may be scan to BIM, CAD to BIM, or direct BIM, or it may be 4D, 5D, all the technology users. They're like BIM specialists. So today, if I look into country like India, we have good capacity of production professionals in the country, but coordinator and management is less. Advisory and leadership is very less. Okay, this is our country's situation with respect to BIM professionals. And obviously, these teams depends on company to company. The contractor team may be different from the client team and the service provider. So a decision making on these is also happening with companies. And the next comes is a software strategy. Obviously, today, any company which is new to BIM or which is halfway through the BIM, when they go to market saying that I want to do BIM full-fledged, they meet these companies. At least in India, I can say these are the companies who are playing the role of software sale and implementations. So in fact, this has an open BIM applications, closed BIM applications, very affordable, very expensive. Some of them are good for building sector, some for good for infrastructure, some for smart cities, some for design phase, construction phase, asset management phase. So when it comes to a company, when they have to scale up, it's also important to understand how they make a decisions on selection of a software. Do I get the software at a very affordable cost? Is it an open BIM? Do I get the trained professionals for it? Like this, there are 50, 30, 40 factors based on which a company can make a decision what technology works best for them. So this is on the software strategy. The next comes is on hardwares and equipments. Obviously, when we speak about hardwares and equipments, these are very critical when you want to do the digital adoption in the companies. So to start with, you may need a workstations, laptops, mobile devices, iPads. It may be indoor scanners, outdoor scanners, 360-degree cameras, 3D printers, experience centers, total stations, AR devices, VR devices, cyber dogs, drones. There are multiple such equipments, including 3D printing, DFMA equipments. So we have understood what are all the equipments required, and there are different capacity with each of these. So it's also important for an organization to make a decision on hardware. What do they need? Today, you can get a scanner at very less cost and also something which is super expensive. So when a company is making a decision to purchase any of these equipments, obviously they have to look in what is the software, what are the teams, and what are the trainings, what are the partners' capacity, and they can go through the hardware procurements. And the next is partnerships. Today, for example, if you go to the country like India, we have hundreds of companies who provide the BIM, different services for the construction sector. Some of them purely do design and engineering. Some of them do geospatial. Some companies do BIM, which is like CAD to BIM, BIM to CAD, scan to BIM, the basic drawing production, these kind of things. Project controls are like some companies are very specialized in integrating the BIM with their ERP systems, 4D, 5D, project controls, these kind of things. And some companies are very focused on VDC, where they take the models, do the site-related simulations for safety, risk assessments, procurement, logistic planning, these kind of things. Reality capture. So some companies are having the scanners, drones, 360 cameras. So based on the project requirement, they come, scan, convert the point cloud to BIM and give it to you. Immersive experience, there are a set of companies who do the VR, AR, mixed reality, set up your experience centers, control rooms, these kind of things. And the last category is digital twin providers who can take your as-built models, link with your building management systems and give the services. So it's also important for our organization to look in which are these companies, what their capabilities are, and make the critical decisions before they onboard any organization. And the next is training. When an organization is getting set up, it's also important to look in what are the kind of trainings. Usually the trainings are into 4 levels: tier 1, tier 2, tier 3, tier 4. Tier 4 is like for the production level, the modelers and specialists, coordinator, which is a technical specialist, managers for implementation and oversight, and tier 1, which is for C-suite strategic level decision makers or people who drive the BIM in the organizations. So we are also providing trainings on these areas from the past 6-7 years now. So what we have done, this is a kind of company which usually not there in many sites. So we are a dedicated company to help all the AECO sector organizations to set up their BIM departments. So we're not getting into projects. We are just focusing on how to enable organization in BIM and digital and help them through the digital transformation journey over the period of 2 to 3 years in terms of business strategy, software, hardware, trainings, change management workshop, and concept development, monitoring, and alignment. So what we have done in the past 6 to 7 years now, we have built the capacity for the Tier 1 category leadership. In market, helping them to do the basic services. Then we started building these leadership in the country through the C-suite executive programs. And we have built some 150 plus leadership in the country. They're driving the BIM in the companies. They're running their own business. So this is the kind of team which has been built. For projects, what has happened in the country is there is no one-stop solution for end-to-end for delivering BIM. So some companies focus on bits and pieces in silos. So when any organization needs BIM or a digital initiative, so single company is not able to address this. So what we have done, we have partnered with different BIM and geospatial and other service providers from 40 cities in the country, some 300 plus companies in these locations. So we are trying to give the one-stop solution for the clients. So this is it from my side. It's more about helping anyone in setting up their departments. So happy to be part of this conference. Let's work together for digital transformation. Thank you.
Okay, thank you. Okay, any quick question? Yes.
Hello, Dr. Ahmed Sibi. Actually, I'm Secretary General of FedMes. I have only one question to you. Most of the country, I found that there are guidelines for the contractors, but now I find out in your presentation about the guideline for the clients. It is interesting to me. So how the clients can get this type of guideline, like the government or authority publish as the hard copy, or maybe they can browse from the internet easily? How can the client get this?
Thank you.
Yeah, thank you.
Yeah. So what is happening here is, for example, as I said, we were developing the local guidelines. This is Bureau of Indian Standard is a national body to have the local guidelines. So we have formed a working groups and panels within this from the bringing the set of clients to form a working group for the guidelines for clients, building all the key contractors coming together to develop the guidelines for contractor, and also for the subcontractors who are going to give different services. There's also a set of subcontractors who have come together to develop the guidelines. So this is an activity which is happening from past 1.5 years in India. And after maybe next 3 to 6 months, we will have the guidelines open for the market within India, which will be published by Bureau of Indian Standards. In fact, I'm sharing this initiative thinking that rather than just following some ISO or following some other guidelines, it's also important to understand what exactly the country is, because it's all about country specific, what the challenges are in their countries. So it will be published by Bureau of Indian Standards maybe in next 3 to 4 months.
Okay, thank you. Okay, now let me invite our next speaker, Dr. Somjintana.
Good evening, everyone. I'm Somjintana Kanangkaew from Chiang Mai University. Today, I will present my topic is a communication system to support evacuation route in building construction projects, a BIM and augmented reality approach. Construction is a high hazard industry comprising a wide range of construction activities. The construction phase records high fire accidents compared to the other phase. Fire is one of the 6 fatal accidents in the construction sector, and it is growing in economic loss of life, and social impacts such as the incapacity to work due to an injury. Because of the characteristic of the construction phase have to continuously change workplace, the number of occupants, the space, and evacuation route change from one day to another. And in the construction project, there has the less protection, such as fire alarm, sprinklers, smoke detectors, and auto-fire suspension system have not been implemented. Therefore, evacuation conditions in construction phase differ from the auto phase, and the disasters are becoming diverse and challenging to predict the appropriate evacuation route. Nowadays, the construction project has non-interactive communication system as the real-time communication. They always use email, drawings, phone calls, WhatsApps, lines, or a side meeting for communication. Therefore, when they are under the emergency situation, most current communication system cannot provide and support evacuation information to construction workers and staff immediately. Many previous research they have identified the cause of high proportion of emergency casualties as a direct link with a delayed evacuation service of the facilities, which the lack of the real-time information update can cause, such as the building users in an emergency, they cannot get the real-time evacuation route. The evacuation plan were usually guided in the 2D views for explain the hazard area and evacuation route in the buildings. But the common user as the construction workers and the staff, some guys, they cannot interpret the construction drawing quickly, understand their position within the building and select the appropriate evacuation route. This study aims to develop a system for communicating to support evacuation routes in the dynamic nature of the construction projects and to provide real-time access to information for evacuating them from the hazard location. Visualization technology is an effective communication tool for fire evacuation system in the construction project. Its advantage include the ability to display the complex data in an easily understandable way, visually identify the hazard area, facilitate the decision making, and promote interaction between the staff and engineer to solve problems. BIM technology can support virtual 3D coordination of the construction activities related to the emergency evacuation, enable to display of the distinct site layout in the 3D visualization, and immediately grasp the file status in the construction project. An augmented reality or AR can enhance the user perception with the visual and promising the technology for improving the visualization of the information directly on the construction site. This study gains ideas from the mentioned problems to develop the safety evacuation tool for preventing and reducing the number of the injuries and casualties from fire accidents in the construction project. The proposed system provides the real-time fire evacuation information by BIM and augmented reality that integrate with the user mobile phone. This is show you about the framework of the proposed system. Seamless information exchange were the significant focus of this study. The IFC file format, the Autodesk Revit and Autodesk Navisworks file format were authorized as the standard file. Firstly, the IFC files is exported into the FBX file format and integrate it into the Unity game engine to create the virtual model in the virtual environment. This virtual model have to generate the data sets of the file axis and markers which display the user location in the virtual environment. Then we have the script used for calculating for the shortest evacuation route, for obstacle avoidance system, and also optimization the number of the user in the building in the real time. For this slide is show you about the proposed system. We have to integrate the evacuation route and the access in the experiment by capturing the image containing the marker. When the proposed system, we have to detect the marker that trigger. There will be display of the user location, and the system have to calculate the shortest evacuation route based on the distance, and we have to recommend for the appropriate evacuation route to the users in the real time and on the real world scene as well. Yeah, this is the primary platform that I used for creating the 3D model was the Autodesk Navisworks. For Autodesk Revit, and we have to integrating the visualization technology was the Unity game engine. In this study, have to utilize a previously developed method of linking the digital model to support the integration of the information in the 3D model. And the developed marker-based location system utilize a marker as a spatial index to connect the physical location with the virtual information. In this study, we have 72 markers with the pattern have to install on the first floor to the third floor of the case study as nodes, such as the rooms, corners, like a file axis, and we have to define in the 3D model in both of the virtual and the real environment as well. A-star algorithm is a heuristic search algorithm that finds the shortest path between the starting node to the end nodes. And they have to use the function to estimate the cost of the reaching the goal, which helped it to search for the optimal path efficiently and approach for a planning collision-free path in the complex environment. Yes, because of the characteristic of the construction project, we involve have many temporary work and constantly changing workplace. Therefore, the evacuation route will be changed every day. The proposed architecture for the real-time obstacle avoidance is an integrated framework that stores location in the 3D model and avoid obstacle in the building. BIM technology is an effective visualization tool that helps to allocate the evacuation area in the building, and Google Spreadsheet, we can allow the user to create, edit, and collaborate by input like X, Y, and Z coordinate of the obstacle observed daily into the Google Spreadsheet to update the changing the construction project, such as the obstacle position, work activities, or work process will be following by the work schedule as well. In this study, I have two case study for experiment. Consists of the first one, the case study A. We have to experiment in the real environment in the normal condition. And case B have to testing by we have the obstacle appear in the construction area. Yeah, this is the case study I have to experiment. It is the engine building of the secondary school construction project. And this is the 2D view of the case study. Yes, I show you from the experiment from the case A. I have to testing with the real environment in the normal condition. The result show that the proposed system we could recommend for the appropriate evacuation route to the user in the real time regarding for the obstacle avoidance. And you can see for this one, it is the user we try to activate our system. And then when we scanning for some markers, some data or some information to evacuating them, it will be show up on the mobile scene. This is the distance. It will be show you and calculate from the current location to the axis. And this is the name of the axis that he should following. And this is the virtual green light to guidance and to move all of them to the destination as well. Yeah, and this is for the case B. I show you this is the 2D view. Actually, this is the current location of the people or the users. Normally for the shortest axis, it should be the axis 2 if it is in the normal or if it doesn't have the obstacle appear here. But in this case, we have the obstacle and temporary work or materials appear on here. It means that the user, they're impossible, they cannot walk through in this area. So my proposed system will be recommend them to use another axis. Yes, this is show you for the real environment that I have to experiment. You can see this is the virtual box in the orange color. It is instead for the axis. You see the axis too, but this one, you can see like the color is not changed. The concept is if some axis is the appreciate axis or appreciate evacuation route, the color will be changed from orange to green, and the virtual green light will be updated and show up immediately. Yes, that I told you, like in this case study, we have the obstacle appear in the area, so it means that we cannot walk to this area. My proposed system will be recommend you to use the next axis, which is the axis 1. Yes, and this is the record video to show you. It will be, you can see this one, the information is not provide on present in the real time, but when you scanning for these markers, yes, my system will be activated and will be show you for the distance from the current location to the axis, and will be show you the axis that you should be go to. Yes, and this one, our system, they didn't recommend for the axis 2, but you can see if I move to another axis, it will be show you, you should be following this line, and then it will be bring you to the safety destination. Yes, and this is the destination you should go to there. The experiment showed the proposed system could provide the real-time access to information for evacuation guidance. Furthermore, the proposed system could recommend the appreciated evacuation route to the user in the real time regarding for obstacle avoidance. If it was impossible to walk through due to obstruction, the proposed system could recommend the user to use the next exit. Therefore, this proposed system is effective and convenient for decision making, helping the user to find the destination quickly and efficiently. Thank you.
Thank you. Any quick question? Yes.
Okay, just want to ask you something. It's very interesting presentation. Thank you. Just want to know what are the data sets that you need in order to, let's say, use it for a different case. What I understood is that you need to have like the BIM model and like what the steps that you want to do.
Yes, actually the data will be divided into parts. For the first part, you should have the BIM model of the building. Yes, and the second part is will be concerned about the obstruction avoidance. You should be updated like for day one. We have some works or we have the updated work or something like that.
That was my next question. So how do you update the obstruction things?
Yes.
Is that updated manually, or are there other additional, like, I don't know, like cameras or whatnot that you want to install in order for that to be assessed immediately?
For now, it's just like input by manually. But for the future work, I try to work it to be like automatic. Yes, like try to use like or CCTV or something, to detect and to make our system to know that, this is the obstruction.
So then one more question, sorry, just one small question.
Yes.
So if,
if I am in that building and I want to run away, so what is the step? Let's say there's an earthquake or there's a fire. What's the step then? So I have to scan the thing that you are saying, and then it will show me the direction of the exit, and that it shows me by using my phone. So the next thing is that I need to have my phone with me.
Yes.
Yes, okay. And I need to know the position of the scanning.
Actually, I try to install like to our every corner.
Okay.
And yes, because if it's like the limitation, like if you have the list install of the marker, it means that you try and hard to find some area. But if you have like many markers, it means that you have the chance to take you to the destination as well. Yes.
Okay, thank you very much.
Yes,
Sorry.
thank you.
Okay, thank you. Let me invite our final speaker, Dr. Adrianto.
Okay. Good afternoon, everyone. Thank you, Professor Hsieh. Today, my name is Adrianto Oktavianus. Sorry. I am from Bandung Institute of Technology, Indonesia, and today I would like to present my research with Professor Chen and Professor Jacobin from NTU, Taiwan, and Concordia University at Canada. And first, I would like to mention about the rising frequency of natural disaster, especially related to the earthquake. The report from the UNDRR state that the natural disaster nearly double in the last 20 years compared than the previous 20 years. And this is the earthquake that happened in the last 3 years, and I'm sorry about the earthquake in Myanmar. Then I would like to mention that how important of the recovery process in these states. Since the recovery phase after the response actually is very important. It's an important phase because it needs the process, a very detailed process for the repairing damage, restoring the services, and also the rebuilding the facilities. And I think for the process of recovery and reconstruction, the building assessment is the first step that we should taking care, and also the recovery planning is more important after that. So, however, the problem in post-earthquake building recovery is so many problems here. One of them is related to the human error and the inconsistent evaluation for the visual inspection. The second one is related to the time-consuming processes for the rehabilitation planning process. And the third one is related to the lack of data. How to make the decision-making and recovery progress is very slow. And based on our experiences in some recovery project, we know that manual inspection can take weeks, and maybe it's delaying recovery and increasing risk to the communities or social for the society, I mean. So in other set, we also, in the construction sector, we also face the decarbonization or the sustainability issue. That's why for this research, this study aims to develop an integrated system using the advanced technology, which is BIM, deep learning, AI-based, and also WMS, web map services. It's for supporting the post-earthquake building recovery. So This is the concept of the sustainable post-earthquake recovery planning system using the BIM, Building Information Modeling, Deep Learning, and also WMS, Web Map Services here. So basically, we combine the building information modeling with the computer vision. Computer vision is AI-driven for the image, and also web map services here. For the building recovery planning process, so the BIM is useful for integrating all data using through the inspection phase, engineering-based evaluation, and also the reconstruction planning. Then for the computer vision, it's very useful for the automatically detect the damage, recognize the damage, and also how to recognize the damage area. Then the result of the computer vision actually is to automatically quantify the volume of the damage area and also the cost estimation. Then the WMS, Web Map Services, I use the Google Map API to generate the maps in the developed plugin and also the roads and distance metric. So this is the computer vision for the building damage assessment. We use computer vision to making automated image and video analysis for assessing the damage after an earthquake. So these are the examples of the result of the computer vision analysis. So computer vision basically has successfully achieved the surface damage classification, and then how to segmentation the area here, the damage area, and also how to detect the object of the damage here. This is the example of the single damage, like a crack here, and also the multiple damage, like a crack, concrete spalling, and also the exposed rebar. Okay. For this work, the computer vision for the structural element assessment, this work developed two tasks. The first one is image classification. The second one is instant segmentation. The first one is it aims to classify the damage in element level. So we can see that we can get the level of the damage for the element level here. For example, this one is the light damage, and the first and the third one is the severe damage. For the instant segmentation, we use the Detectron tool. It was built by Facebook AI research. Is to detect pixel by pixel in the image to know the damage in the image. For example, this one, we detect the element here and detect the damage in the image, and also we combine it. So we can get the ratio between the damage and the element from the pixel. Based on the pixel, we can convert it into the real measurement, which is the centimeter or millimeter. And this one is the conceptual integrated system. Basically, we developed the BIM-based UI plugin here to assess the damage and also to planning the recovery for after the earthquake. So basically, we can put the image here, and we can get the result from the deep learning process, and then we combine it with the WMS here to get the map API and route analysis to know the distance between for the recovery planning. So basically, for the sustainability consideration, we consider the economic analysis, the carbon emission for the material and equipment, and also the transportation. We also consider the health and safety evaluation here to know how we should prepare for the PPE for the reconstruction project. So the output, it should be sustainable building rehabilitation plan here to get automatically quantity take-off, cost estimation, and also the rehabilitation method here. So this is the demonstration for the BIM-based plugin here, how to connect with the deep learning-based analysis with the BIM using the element ID, and also we developed some parameters to get the quantity takeoff and also to get the cost estimation here. Then we also, this work also develops some analysis for the environmental field here to know about the carbon emission from the material and equipment, and also the transportation planning. This system also analyze for the PPE planning and also the debris potential here. So this is the workflow of the system. So this is the output of the system, developed system. Basically, this system will generate the report for the damage element, how many elements that classify on the first level, the second level, and third and fourth level. Then also get the economic analysis, which means about the budget for the reconstruction project, and also the environmental impact for the reconstruction project. As the extension of our work, we also develop a mobile application for collecting image data by capturing the image and also storing the image based on the BIM element ID, and we store it in the cloud services. So this system, we use the Revit, Autodesk Revit, and also the Unity 3D mobile application, and this is the demonstration of the mobile phone application. So in another work, we also develop a framework for the BIM-based post-earthquake building recovery, and basically it covers the several phases here. So how to use the BIM in inspection and data collection, and use the BIM for the deep learning and damage assessment. Then how to use the BIM for the rehabilitation planning, and also updating the BIM data for the next phase, like for the asset management. So as conclusion, the building information modeling data is essential. I mean, is required for the system. So we know that currently the BIM is not applied for every building, but in the future we hope that each building will have a BIM model, and then it can it enables to get a more faster and data-driven response for the post-disaster scenario. And then for AI-driven computer vision, it enhances the system by enabling the rapid damage assessment from the visual data. It's improving the efficiency and reliability of the assessment. And then the integration of web map services bring the special context. I mean, like the GIS base, we can develop the web map service more again to support the sustainable and coordinated recovery planning in the regional scales. So to sum up, the integration of BIM, computer vision, and web map services has the great potential for improving the overall quality for the building recovery after the earthquake. So thank you very much for your listening.
Okay, any quick questions for this one?
He's my colleague, close colleague, but I never asked directly, so now I will ask you. So actually, it's very, very interesting presentation, and also the whole technology is amazing. I think a lot of us can imagine how powerful it can be if we can implement that. So actually, my question is, if we are the government in any type of country, let's say you want to think about going into that direction, Can you maybe suggest what are the most important things to consider in order to start implementing this? Just from the top of my head, by thinking of this, I think the most difficult part would be to have the BIM modeling of the data set. But I don't know, maybe you can give us some insight about what is the most challenging aspect in order for like any country to try wanting to go to that direction.
Okay. Thank you very much for your questions. In my opinion, there are two challenges for applying this system. The first one, yeah, you are right, is a BIM model. Yeah, we know that currently, just a few buildings that has the BIM model. Yeah, but in the future, I hope that every maybe mid to the rise building will have the BIM model. We hope. Yeah. The second challenge is about the data set. I mean for the image data set. It's for training. It's important for the AI to train with the enough data set for the good with the good data set. So it's important to get more and more data set. I mean for the image data set, and so we can train the machine better, and also we can get the result better. So there's two challenges in my opinion.
Okay.
Yeah. I think, for the strategy, I think the critical infrastructure, you are right, is the most important for the society. And then maybe like a hospital or some government buildings is more important. But we also have to take care with the residential buildings. I think it's more important for the urban scale.
Okay, thank you. Yeah. Okay, so we still have a few minutes, and then we have 2 speakers online and 3 in the room. So any other questions for them? Yes.
Let me introduce myself. I'm Dr. Ong, and working in one of the private college in Myanmar. So I'd like to ask the first presenter. Maybe he will online.
Yes, I'm here.
I noticed we use the AI tools for the damage by vision method technology. So let me clear this. I saw your architecture of the AI model. So it is the generated AI model or traditional AI model? Please.
Okay, thank you. Can I speak? Let me show the network again. Yes, this is what we have developed. And this is not related to the generative AI, which is, I don't know whether it is traditional or not, but it is kind of deep learning model with so-called convolutional neural networks with multiple layers. And at the same time, I have one more AI model, which includes the generative AI, the so-called stable diffusion, which is a kind of image generator to kind of normalize the image. So my answer is maybe yes and no.
So this slide, I noticed there is a decoder and encoder. That's why I asked the question. Normally, this is a variable auto encoder generated AI model. That's why I.
Okay. Thank you very much. Yes, you are right.
Okay, thank you.
Thank you.
Any other comments, suggestions? No? Yeah, I think it's kind of fair. Everyone got some questions. All the speakers actually got questions. Okay, so I think we've got 3 minutes left. But I want to make a quick announcement that our next TC-34 seminar or session will be in the CICA 10. So CICA 10 will be held in October 21st to 24 in Jeju, South Korea. And then within that conference, we have already secured TC-34 technical sessions over there. And we have already got 8 presentations. So please join us in Jeju in October, okay? And at the end, I want to thank everybody participating in this joint technical seminar, both online and in person. Okay. Thank you very much. Thanks.